Hello everyone and welcome back. So I wanted to create these diagrams to explain the overall workflow of creating simulation in Houdini. And I wanted to explain it in a way that will make it easier for us to teach later and everybody understands where the steps and what needs to be done to make this workflow as efficient as possible. And as we go, we're going to be modifying or creating our own tools to fill in each of these steps. Okay, so what do we have in general? We have a source which can be made of points, lines, or geometry. We take that source and create a volume from it. This would be a density field, this would be a temperature field, or anything that we could pass into the solver. Then the solver takes all these inputs, takes all these volumes, and starts simming. You give it data, it's going to run its calculation, and it's going to give you something back. So in this case, for example, we can take a sphere. Let's put some geometry here. Sphere. So let's say we take a sphere, we convert that sphere into a volume, and then we pay a density volume and we pass it into the solver. Let's just call it volume. We pass it into the solver is gonna run the calculation needed and give us back a volume field. Now, as the simulation goes, it takes in, let's say, a density field, and it generates more than that. Because we have movements, we have temperature, we have a combustion model, it can generate temperature, flame, burn, velocity, divergence. All these things are internal to the solver, and when we want to render, we need to export and save the data that we need to disk. So in this case, we have a sphere going into the solver. We can inject extra force. For example, we can have a wind, we can have a character moving along and injecting velocity into the sim. We can have a collision geometry, we can have a wall, a car, a ground, anything. All that will be taken into consideration when running the solve, and then it gives us back volumes or volume fields. These volume fields, they are generally not compressed. They are raw data, okay? Because the solver needs to use the highest, well, it cannot use compression because that will ruin the data and the math and numbers behind the sim. So the data is always raw. We export and stream out the data that we need and rerun it through an optimization workflow. Now, this optimization workflow is something generic. We can go into more details later, but for example, we could take the density field and compress it instead of 32 bits into 16 bits. We can take the density field, which generally fills the entire domain, and mask it to only be present where there is density. This will save a huge amount of disk space. We can take that. We can take the data and lower it. We can lower the resolution of a volume. We can generate points that we will use. We can fill the density with points and sample the temperature to give us a quick preview with points instead of having to display the viewport, for example, the volume. We can save it to disk. We save it to disk as VDB, and that's what we will render in Arnold, Redshift, and or Mantra. VDB is the format that we will use. It is a volume format developed by DreamWorks, and it's natively integrated in Houdini. Now, Houdini also has other types of volumes, or the Houdini native volumes, and that is what's being used in all the calculation inside of the solver. Okay, so everything happens with Houdini volumes, and then when we compress it or when we save it to disk, we convert it to VDBs and then save it to VDB. Okay, so this is the general workflow. Now, what we can do is, because we have these steps, we can work on each one of them and make it and customize it the way we wanted it to be. Let's say we want to emit explosion. Okay, we can create our own spike system, our own emission system. Okay, you select a point and then it creates lines, and then you randomize those lines and you create like cones, and you place it on top of these splines and convert those cones into volume. You then create velocity, and that will be your source. Okay, same thing for the solver. We can dive deep. and customize it. Same thing for the fields. We can import specific ones that we need. We can delete the ones we don't. We don't have to. We can customize each of these steps. We can customize the collision geometry. We can customize forces, the optimization workflow, except the safe. So each of these things we can go and dive into it and make it as custom as we wanted it to be to give us the control that we want. And as we practice, we're gonna see a connection between all these steps, like what the source and how is it, how does it look like, how is it moving, how big it is, and how fast it is, and how many points, and what kind of fields, and how all of that goes into the solver. So all these things are chained and connected together, and we're gonna learn how to customize and create all of these steps. Now, what side effects did is, with the latest Houdini 18.5, which I don't recommend using at any point before maybe week 6. Okay, we don't want to use any of the new stuff because it's just gonna skip, and it's gonna basically, it's gonna skip a lot of the important things that we want to teach you. So what side effects did is they looked at a variety of workflows and how people are doing things, including our workflows, and they've designed a system that tries to compensate all of the workflows and gives those control, which is great. It's amazing. So, but we don't want just to use that. We want to be able to create that, customize it, change it, and fully understand how it's working and why it's behaving like that. The other important thing as well is Houdini SOPs is a crucial part of learning Houdini. The more you know about SOPs, the better artist you are. And by simply using pre-built solutions from side effects or any other artist, we are not giving you guys the important information that we need. Everyone has to know Houdini inside out to get to the senior level, or the level that very few has, and that's the one that will make you stand out. If something becomes accessible and it's easy, everybody can do, then the market will quickly get crowded, and it will be really hard to stand out from the crowd because it is accessible to everybody. So we don't want that. We want to have the edge and be able to create something custom and control it and fully understand how to do it. So that's why we're gonna dive deep into all of this. In the next video, I'm gonna explain the new combustion model briefly, and then we're gonna continue and move on to some more stuff. Thank you guys for watching, and see you in the next video. Bye bye.